Welcome back, Grade 6, to Nelson Math, Chapter 7, Section 2, Investigating Properties of Triangles. We're going to be looking at triangles from a couple of different ways. And that way, it'll help you understand more about triangles because if you know one property, you automatically are given another property. So let's look at some of these examples now. Let's start off with a definition. In a opposite side, in a triangle, the side and angle does not touch. For example, the opposite side of angle Q is Q. Here is angle Q, the uppercase or capital Q, and here is lowercase q. So Q, line Q, or side Q, is opposite angle Q. Angle P is opposite side P, and angle R is opposite side R. Let's look at these triangles right here. So the side opposite angle D, so this is angle D, the side opposite would be the side length it's not touching. So it's touching this one, it's touching this one, that means it's not touching this one. So this line that goes from E to F is opposite D. And let's look at this one. M is not touching the line that goes from N to O. So the side opposite M is 1.7 centimeters. The side opposite angle O, which is 80 degrees, the side opposite angle O is this side right here, 5 centimeters. So if you're given a side, you can figure out the opposite angle, and if you're given the opposite angle, you can figure out the side. Let's take a look here. All three of these sides of our triangle are all 5 centimeters. That makes this an equilateral triangle. Any triangle that has all three sides exactly the same, an equilateral triangle, must have every angle inside that triangle at 60 degrees. Our sum of the angles in any triangle we already know is 180 degrees. But when those three angles are the same, they must be shared equally inside that 180 degrees. The only number that works is 60 degrees. It works the other way as well. If you know that the inside three angles are all 60 degrees, it must be an equilateral triangle because the opposite sides of the 60-degree angles must all be the same. Let's take a look at what it may look like in this triangle right here. This is an isosceles triangle, and we know it's an isosceles triangle because this side length is 5 centimeters. This side length is 5 centimeters. So we have two side lengths that are the same and one side length that is different. So let's take a look at the angle measurements across from the side lengths. This side, which goes from M to N, we'll call side MN, it's 5 centimeters long, and the opposite angle is 80 degrees. This side, which we'll call MO, is also 5 centimeters, and the opposite angle is also 80 degrees. So in an isosceles triangle, two of the angles must also be the same. Not just two of the sides, but two of the angles. Lastly, the side opposite angle M, this is the smallest angle at 20, is opposite the smallest side. So for example, if I only gave you the 3-degree measurements and I told you I have a triangle that has three sides, 5 centimeters, 5 centimeters, 1.7 centimeters, and I gave you the three angles, 20 degrees, 80 degrees, and 80 degrees, the 20-degree angle must be opposite the shortest side because it's the shortest angle or the smallest angle. The opposite is also true, or we call it the corollary. If I give you three angles, 20 degrees, 80 degrees, and 80 degrees, then I know that the smallest side length must be opposite the 20 degrees. Those are all properties of triangles which you can use as clues to make and build and label a triangle. Thanks, everyone. Have a good day.